Hi guys, this is Mr. Urrego, and today we're solving logarithmic equations. Right now we have log base 3 of 9 equals x. So whenever we have only one logarithm, we're going to use the definition of logarithms, which means I'm going to rewrite this as an exponential. How? I'll take the base, 3 to the x equals 9. Okay? So 3 to the x equals 9, and from there I'm going to solve for x. 9, 3 times 3, which is the same as 3 to the second power. And the property says that if the bases are the same, my exponents are the same. Therefore, the value of x is equal to 2. And that's my answer. Let's do another one. I have log on base x of 8 equals 3. Okay, now my variable is the base. Same thing, only one log. Therefore, I'm going to rewrite x to the third power equals 8. Now, as soon as you rewrite an exponential, now we have to solve. Okay, I have to solve this equation. X to the third power, I have to do cube root on both sides. Cube root is going to cancel the cube, so I'm going to have x here, and cube root of 8 is, and my answer is 2. Now let's do another one with a little bit more. Now we have this. That's again only one log. Therefore, we write 4 to the second equals this. 4 to the second equals x plus 3. From there, I solve the equation. 4 to the second is the same as 16. X plus 3, solve for x. Minus 3 minus 3. 13 equals to x, and that's my answer. You want to plug it back in to double check. So I have log on base 4, 13 plus 3 is going to give me 16, and that's equal to 2. I'm checking my answer, that's what I'm doing. Now let's rewrite this. 4 to the second is equal to 16, which makes sense. Therefore, x equals 13, that's your answer. Now let's practice something with ln, natural log. Only one logarithm, which is natural log in this case, but I have a 3 on the outside. So this 3 is multiplying my natural log. Therefore, let's get rid of that. Multiplying, divide on both sides. Got rid of the 3. Now I have ln of 2x equals to 4. Now I only have one natural log. But again, what is my base? So let's rewrite natural log as log on base e. Remember, ln is the same as log on base e. So of 2x equals 4. And same process, I'm doing the definition of natural logs. So let me do e to the fourth power equals 2x. E to the fourth power equals 2x divided by 2 on both sides because I want to leave the x by itself. And e to the fourth divided by 2 is equal to x. And that's my answer. I want to go back and double check my answer. Let's plug it back in. So I have 3 ln of 2 times x. But x is e to the fourth power divided by 2. And all that is equal to 12. Okay? A little bit bigger. Okay. So this 2 and this 2 cancels out, and I have 3 ln of e to the fourth power equals to 12. Okay? Now, ln of e cancel out, and my exponent drops. So I have 3 to the fourth, 3, that 4 is going to drop, times 4 equals 12, which is correct. So my answer is this. Make sure you check the video about all different properties of natural logs and logarithms. Let's do another one. Now I have 2 logarithms, but they're on the same side of the equal sign. Okay, and I have a number on the other side. So the idea is the following. Because I have a number on the other side, I can still use the definition and rewrite this as an exponential. So what do I do with these 2? This is a sum. I need to condense. When it's a sum, it's going to condense as a product. Check the video. So this is going to become log on base 2. I'm going to condense the arguments now. So this is going to multiply I'm going to have x times x minus 7. And that's equal to 3. So a sum condenses as a product. Once I have this, I can rewrite it because now I only have one log. So let's rewrite this. 2 to the third equals this. 2 to the third equals x minus 7. From there, let's solve the equation, and that's it. 2 to the third gives me 8. And x times x is going to give me x squared, and this is going to give me minus 7x. Because I have a quadratic, then I have to factor. Make that equal to 0. Minus 8, and I have 0 equals x squared minus 7x minus 8. From there, I gotta factor and solve for x. So x squared minus 7, two numbers that multiply get negative 8, but when you add or subtract, you get negative 7. That's right. So my two factors are x minus 8, x plus 1. Negative 8 times 1 is negative 8. Negative 8 plus 1 is negative 7. So this is how you factor. Equals to 0. That means I gotta find the values of x. X minus 8. The value of x is gonna be 8. You just change the sign. And here, x plus 1. The value of x is negative 1. And those two are my answers. Now we have to double check the answers. Okay. Let's try the first one. Let's check x equals negative 1 in my original. So I have log on base 2 of x, but x is negative 1. Plus, and I need to rewrite everything else. But now I can stop here. Can I have a log of a negative number? No, it's impossible. You cannot have a negative number as a log. Therefore, this is not possible. Therefore, that answer becomes an extraneous solution. Extraneous solution. All right. And now let's try the x equals 8. Let's plug in the 8. So I have log on base 2 of 8 plus log on base 2 of 8 minus 7. That should be equal to 3. Log on base 2, 8 is the same as 2 cubed. Plus log on base 2, 8 minus 7 is 1. And that's equal to 3. Remember, this 3 comes here. So 3 log on base 2 of 2 plus logarithm of 1 is always 0 equals to 3. And now I have here log on base 2 of 2. This becomes 1. And 3 times 1 is 3. Plus 0 equals to 3. Again, I'm applying properties of logarithms. Check the video, please. So therefore, my answer is x equals 8 because this one is an extraneous solution. Let's work at a few more of this. Now we have this. Same, two logarithms on one side of the equation, but I have a number in the other side. Meaning I can condense this. Because it's subtraction, then it's going to condense as a division. So I have log on base 2 of x plus 2 on the top over x minus 5 on the bottom equals to the same thing. Now I condense 2 into 1. Once I have one logarithm, then I can rewrite as an exponential. That means 2 to the third power is equal to x plus 2 over x minus 5. Once I have an equation, it's just a matter of algebra. Okay? 2 to the third power is 8. And then I have x plus 2 over x minus 5. And now, cross multiplication. Okay? Let's work it out here. So I have 8 that multiplies x minus 5. 8 that x minus 5 equals 1 times x plus 2, which is x plus 2. And from there, just solve. That's going to give me 8x minus 40 equals x plus 2 minus x. That's going to give me 7x minus 40 equals to 2. And then I have 7x equals to 42. Divided by 7, x equals 6. That's it. I got to go back and plug it in to see if that 6 is going to work out. Log on base 2 of 6 plus 2 minus log on base 2 of 6 minus 5 should be equal to 3. Log on base 2 of 8 minus log on base 2 of 1 equals to 3. We said that log of any base of 1 becomes 0. And here I have log on base 2 of 2 cubed. We notice that these two cancel out, base argument is the same, therefore my answer is 3 minus 0 equals to 3, which is right. So x equals 6 is the right answer. Let's try doing a few of them with one-to-one property. Now if you notice, I have logs on both sides of the equation and they have the same base. So the one-to-one property says that if the bases are the same, the arguments are equal. Therefore, 5x plus 2 becomes equal to 7x minus 8. And now I have an equation easy to solve. Minus 5x minus 5x, 2 equals to 2x minus 8 plus 8 plus 8, 10 equals to 2x divided by 2, x equals to 5. Always go back and plug it in. So log of x is 5, 5 times 5 is 25, plus 2 is 27, equals log x equals 5, 7 times 5 is 35, minus 8 is 27. Both of them have the same base. You see that when I replace the x by 5, both sides are equal. Therefore, this is the right answer. Let's try another one like this. Now we have this. No base, meaning base 10. Do I need to write it down? No. So I'm going to erase that base 10. So the idea is every time there's no base, you have a base 10. Remember that. And that you can plug in the calculator if you need it. Now, I have log base 10 on both sides of the equation, therefore one-to-one property. But there's a 2 here. But again, there's nothing that I can divide by. But if you remember, that 2 is an exponent for my argument. Therefore, I can rewrite this as log of x squared is equal to log of 25. Logs are the same, therefore my arguments are equal. So x squared is equal to 25. And now I have an equation. How to solve this? Square roots. Square root on both sides. Remember, the square roots cancel the square. But as soon as I do square root, I will have a plus or minus in the other side. And the square root of 25 is 5. That means I have a positive 5 and a negative 5 as my answers. We got to check the answers. So let's check negative 5 first. X equals negative 5. Plug it back in. 2 log of negative 5. Before I keep going, can I have a log of a negative number? No, not possible. Therefore, x equals negative 5 is extraneous solution. It's not an answer, it's an extraneous solution. Let's try x equals 5. Now I have the same thing. 2 log of x, instead of the x, I'm trying the positive 5, equals log of 25. Remember, this is an exponent, so let me bring it back over here, and I have log of 5 squared equals log of 25. 5 squared is 25. Both sides are equal, therefore my answer is x equals 5. Negative 5, extraneous solution. Let's try a few more. Remember guys, if you haven't subscribed to the channel, like the video, comments, ask questions, give me topics for other videos. Alright, let's keep going. Now let's try this one as a little monster, right? It's getting bigger, and now we have a ln. Doesn't matter? It doesn't matter. Alright, you can have any kind of base. So first of all, I have a natural log on the other side, and I have two logs here. It's a plus, so they condense as a product. Therefore, I'm going to have ln and the product of the two arguments. The two arguments are whatever's next to the natural log, okay? So as the product of those two, I'm going to have x minus 4 times x plus 1 equals to x minus 8. Now I only have one log on both sides. As soon as I have that and they have the same base, the arguments are equal. So this equals to that. So I have x minus 4 times x plus 1 equals to x minus 8. And from there I gotta solve. I have a product here, so x squared plus x minus 4x minus 4 equals x minus 8. Because I have a quadratic, I have to combine everything and make it equal to 0. X squared, x minus 4x is negative 3x minus 4 equals x minus 8. Now let's bring these two in one shot. Minus x is going to give me x squared minus 4x, and plus 8, negative 4 plus 8 is going to give me positive 4. And I have a quadratic. I got a factor. Two numbers that multiply get 4, but you add or subtract, you get a 4. 2 and 2 both have to be negative, so it's negative 2 times negative 2. Therefore, it's going to be x minus 2 equals 0. Let's double check. Negative 2 times negative 2, positive 4. Negative 2 minus 2, negative 4. So this is how do you factor this trinomial. Therefore, what's the value of x? It's the opposite sign. So the value of x is x equals 2. Because they're the same, I just need 1. So my answer right there is x equals 2. As soon as I get my answer, what do I need to do? I got to go back and plug it into the original function. Let's do that. So we have ln of 2 minus 4 plus ln of 2 plus 1 equals ln of 2 minus 8. I hope you noticed already. Here I have ln of negative 2. Can I have a negative 2? Can I have a natural log of a negative number? Cannot have that. Therefore, x equals 2 is extraneous solution. But that's the only answer that I have. So what happens? Because the only answer that I have is an extraneous solution, so there's no solution to the problem. So they ask you for an answer. Answer could be no solution. Because there's no answer, you can also have empty set. That means empty set. Or you can have also, there's nothing in between those braces. Therefore, it's the empty set, no solution. That could be any of those answers. Okay? And that happened because that answer that we got became an extraneous solution. Let's do one more. Now, let's stay with natural log. As always, we have a log on the right side and we have a couple on the left side. That means we have to do a one-to-one property. I have 2 here with a minus. We got to condense them. Because there's a minus, they become a division. So these two are going to condense as ln of x plus 2 condense, a minus condense as a division. So that goes to the bottom. And that's how you condense those two. Equals to ln of 1 over x. Natural log, they're the same base. Therefore, my arguments are equal. So I have x plus 2 over 4x plus 3 equals to 1 over x. And now I got to solve this thing. Because I have a fraction equal to a fraction, the easiest way to start with this is cross multiply. Therefore, I have x plus 2 times x equals to 1 times 4x plus 3. Solve. Distribute. X times x times 2 equals 4x plus 3. Okay? Let's finish here. Let's subtract that in one shot. So I have x squared. And now I have minus 4x on both sides. So 2x minus 4x is going to give me negative 2x. And then I have minus 3. And that becomes 0. Okay, now I have this trinomial, I gotta factor it. Let's see if we can factor. Two numbers that multiply, you get negative 3, but when you add, you're gonna get 2. Interesting. So I have x minus x plus 3 and 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So this is how you factor it. Now what? The values of x, everything equals to 0, so the value of x from here is the opposite sign, so x equals 3, and from here is the opposite sign, minus 1, so it's x equals negative 1. All right, now I'm going to try these two values into the original function. Let's see which one works. So I have ln of negative 1 plus 2 minus ln of 4 times negative 1 plus 3 equals ln of 1 over negative 1. Okay, so here I have negative 1 plus 2 is 1, and this is fine. Minus ln, 4 times negative 1 is going to give me negative 4 plus 3. What's happening here? I'm having negative 4 plus 3 is going to give me negative 1. Can I have natural log of negative 1? No, I can't. So this is not possible. I cannot have a negative natural log or any logarithm of a negative number. Therefore, negative 1 is going to be an extraneous solution. Right? So that's not going to work out. Let's try x equals 3. So is my second answer. Same thing that I just did here. I'll have ln of x is going to be 3 plus 2 minus ln of 4 times 3 plus 3 equals ln of 1 over x, which is 3. This is going to give me 5. Ln of 5 is going to give me 4 times 3 is 12 plus 3 is 15. Ln of 15 equals ln of 1/3. Because it's a difference, this is going to condense as a division. So I'll have ln of 5 over 15. And that's going to be equal to ln of 1/3. If you notice, I can reduce this. Divided by 5, divided by 5, this is going to be ln of 1/3 is equals to ln of 1/3, which is the same thing. Therefore, my answer, x equals 3, is a valid answer. That's a good answer. That's an extraneous solution, so this doesn't work out. Okay, and that's it for today, guys. Please like the video, subscribe to the channel, comment, ask questions. Tell me what you think about all this lesson. All right? Give me ideas about future lessons. Algebra 1, Algebra 2, Pre-Calc, Geometry. All right? Thank you for watching. I'll see you in the next one. Take care.